So now we're going to graph this polar equation. It's r equals sine of 3 theta. But before we set up our tables for this, we want to think about how many values do you think we need for this one. And this one, we're actually going to need a little more than we did last time. And the indicator for us here is just this right here. You see this sine of 3 theta? Now, kind of remember the values we picked for the previous videos. It was 45 degrees, right? Every 45 degrees. And one thing I realize here is that if I did every 45 degrees, then I would have to times it by this 3 here. So that would mean that we would be dealing with a lot larger angle than the 45 degrees. And the 45 degrees is just a nice little idea. I don't have to use 45 degrees even if I didn't want to. I could use other degrees. But I just have to have enough points to try to understand what's going on. So 45 degrees seemed to be a really nice interval for us to use. So anyways, back to the problem at hand here. So again, I'm going to want to think about the idea of what would make that 45 degrees. So I would pick intervals of 15 degrees here, because 15 times 3 here would be 45 degrees. And that takes me back to where or what values I would want. Okay, now again, like I said, you don't have to pick the same values or think those intervals are the best. You can just pick any intervals you want to break them down into. Just make sure you get enough points to understand what the graph is doing. Now, using the idea of every 45 degrees in a sense, what if this was like a 4 there instead of a 3? Then that means that would be going every 11.25 degrees. So again, we're not stuck on these intervals either, like 30, 60, 90 for theta. We can actually pick any value we want. So just kind of keep that in mind too. But again, I like to stay in this little box, I guess, with the values that I know. So anyways, I'm going to set up those tables. So notice that I put 2 stacks of 6 here. And again, I already know what it's going to graph, so I know how many I need. But anyways, just make sure you give yourself enough. And don't think that you have to limit yourself. So now I'm going to fill in the table. So 0 degrees, 15 degrees, 30 degrees, 45 degrees. Now if you notice, I just went to 180 degrees with this one. So now I'm just going to fill in the R values. Make sure you have your calculator in the right mode. Oh, and just one more thing. If you're going to graph these on your calculator, you have to make sure you're in radian mode or it doesn't give you a graph. So we can actually graph these in our calculator. And I'll show you that at some point. Possibly. We'll see. Okay, so anyways, so remember, decimal approximations is sufficient for these. So I'm just going to fill that in. So 0 degrees we know is going to be 0. Okay, and then from there I'm going to plug in my 15 and so on. So there's my table there. Just fill yours in the same way. If you can pause it here if you need to go through the values. But that's what we have for our values for that. So now we're just going to graph these. So then for my first point, it's 0, 0. So I'm going to put that in there. And then my next point, if you look at the next one there, and I'm just going in order just so you guys know. So when I look at that second one, I'm looking at this one here. Okay, so I'm going to do 15 degrees, and it's going to be 707. Now for this one, I'm going to go out a ways. For my number 1, number 2, just because I get this 0.707, and I'm not going to exceed a 1 or a -1. So I'm going to make this a little further. So I made 1 the furthest distance out here, and you kind of see how I broke it down. 0.25, 0.5, 0.75, and then 1. So my first point is 0, 0, okay? Then my next point is going to be at 15 degrees, and that's going to be 707. So it's just a hair before the 0.75 on the 15 degrees. So that's probably a good spot for it. So now my next point is going to be at 30 degrees. And it's going to be 1. And then my next point is going to be at 45 degrees. And it's going to be 0.707. Now keep in mind, it's going to be at the same place over here for this one, but on the other side. So then my next point is going to be back at 0 again. So now I'm back here again. Okay. And then my next point then is going to be at 60 degrees. Oh, that was at 60 degrees, I'm sorry. So at 60 degrees, it's going to be 0. Okay, and then at 75 degrees, it's going to be negative 707. So now keep in mind here that this would be the direction I'd go in if it was positive. But since this is negative, I'm going in the other direction. But remember, still on the same angle, the same line in a sense. So it's all got to follow the same line here. Okay, and I'm going to go 707 that way. So now we're at 90, sorry. We're at 90, and that would be generally this way. But again, that's negative. So we're going to run it this way, and that way it says it's 1. I mean negative 1. Okay, but anyways, 1 in that direction. Okay, so anyways, so now the next one then is going to be at 105 degrees, which is here. But it's going to run this way. And that's going to be at 707. And then at 120 degrees, which is here, it's back at 0 again. All right, and then my next one then is going to be 135 degrees, and that's here. And that's going to be 707. So I'm going to go all the way up until there about. And then the next one is 150 degrees, that's here. And there it's going to be 1. And then 165 degrees, and it's positive, that's why I'm going this way. It's going to be there. And then 180 degrees, which is here, puts us back at 0. Sorry about this line over here. That was a typo. So I'm just going to get rid of it. Okay, so anyway, so those are the points. So now what I want us to do is I just want us to kind of follow these, and we're going to draw them of what we did first, what we did second, and so on. So when I go this way, that's what we did. And this is what we call the rows. Remember that? In the last video, I kind of showed you the different ones. But that's what we actually end up with. And plus, you've seen the mapping there in our direction that we went in with this one. So this is a good one. But remember, yes, this one here is because in the homework, sometimes they ask you to classify. So anyways, there it is. Now, you know how many values we needed for this. Now, notice this one actually graphed it only going to pi. So some of the graphs are 2 pi, some of them are pi. They could just be different values sometimes, but I think those are the most common. Either I finished the complete graph in pi, or I finished the complete graph in 2 pi. So just something to keep track of too as you pick all these values. And those are the important things you're going to want to take away from this, because when you get to the calculus classes, sometimes those intervals can only run to or I only need a portion of it, like maybe just this first leaf here or something like that. So those are kind of the ideas that come up later on when using polar equations. Okay, so that's my graph.